Okay, so the second part of this lesson, because the first part was basically review, is I want to re-go over how to simplify the square root of something. Okay, so we can simplify the square root of a number multiple ways. So I am going to show you 2 ways, and then you are going to decide which way you like better, and that's how you can do the practice, okay? The first way is the fastest way, and that's by finding the biggest perfect square. Okay? So, let's say we're trying to find the square root of 48. What you're going to do is you want to find the biggest perfect square that goes into that number. And remember, a perfect square is like, okay, 2 squared is 4, 3 squared is 9, 4 squared is 16. These numbers right here, these are what we call perfect squares. Because when you square root them, you get a number, a whole number. Okay? So one way that you could do this is you could go to y equals and you could put 48 over x in your calculator, go to the table, and see what the biggest perfect square is that's a factor. If you do that, you will notice that 16 times 3 is a factor pair of 48. 16 times 3 equals 48. So if we can kind of like separate square root of 48 to square root of 16 times square root of 3. And as we know, the square root of 16 is 4. So our simplified version is 4 square root of 3. That's one way of doing it. A second way of doing it is finding the prime factorization. This is like if you're not that comfortable with knowing your perfect squares, this might be better for you. So square root of 48, you're going to break this down into prime numbers. So like basically 2s, 3s, 5s, whatever. So think of any 2 numbers that multiply to 48. I think of 6 and 8. I can keep breaking down 6 to 3 and 2. I can break down 8 to 4 and 2, and I can break down the 4 to 2 and 2. So all these numbers now are prime numbers, right? They can only be broken down to the number and 1, which is like 1 is not helpful. What you're going to look for now is you're going to look for doubles. So for example, I have a double of 2's and I have a double of another 2's. So I can actually rewrite this as the square root of 3, the square root of 2 squared, and the square root of 2 squared, right? These are my doubles. These are what I circled. Now, if you remember, when you square a square root, it actually cancels out the square root. So we have the square root of 3, and then we have 2 times 2. Now 2 times 2 is 4, so we have 4 square root of 3. And that, as you see, you get the same answer. So it's really whatever you decide. Just if you do the prime factorization, you're looking for doubles. Biggest perfect square, you're looking for the biggest perfect square. Awesome.